Welcome to the final experiment for this lab semester. We'll be doing a thermal expansion metal lab. This first video is going to be based as instructional on the setup and for getting some initial data. What initial data is we need to find how long the metal rods are going to be. We'll be doing 4 of them over the course of these videos. Aluminum, or as I like to say, aluminium, brass, steel, and copper. And the first thing we're going to need to do is get the initial length of these various metal strips. So, my video could come over here and
They can't read things upside down?
Well, not really. I can't. So let's see. I have this at starting at 10 centimeters. And it looks like
No, it just made it worse.
read it off the photograph. That's pretty readable. That would be for the copper. Steel. Again, I have it on the 10 centimeters.
No, lower.
And okay, you should be able to get the length off of that one. And this was steel. Okay, here's the brass. That's a pretty good shot there. And here's aluminum. Again, it's 10 centimeters on the other end. So you're going to subtract 10 off all these numbers. Alright.
Am I not allowed to? No.
Okay, now for reading the scales here, we're doing a lot of close-ups on the experiments. Oops. Basically, every one of the, as you see here, the arrangement from 0.01 millimeters, which is, boy, this is really sensitive. Every one of these tick marks is 0.01 millimeters. Once around is 1 millimeter. 10 times around gives a full range of 10 millimeters. Now, all these runs will fall between 0 and 0.1 millimeter. The aluminum will be a little bit over. So reading these here, we'll be setting it to 0. We'll let the metal apply heat, and of course it'll expand to a final dimension. And so we're reading the measurements off the gauge. So in this case, 0 to 50, well, that's 1/2 a millimeter, 50 hundredths, so 1/2 a millimeter. Okay. So let's go to the setup. Well, it's basically going to be a tube. It's a jacket, steam jacket. We have something to generate steam with, and it would ultimately be plugged in, piped in, and plugged in. A thermometer for measuring temperatures, a discharge hose, and just something to catch the steam condensate. Now, this experiment is wrought with possible sources of error. So let's do one. Which one do you want to do? Steel, aluminum, copper, or brass?
Which one's the gold one?
This one?
Yeah.
That's brass.
That one.
Okay, do brass. Okay. Nose is a pointy end and a blunt end. The significance of that is on this item is a little detent. And you really want that pointy end to be securely in that. What's going to happen is inside the jacket, the metal rod is going to rest between the thumb screw with the detent and the plunger of the gauge. And when it expands, it'll move the gauge. It'll move the dial gauge. Okay. So a couple things. Goes in the steel jacket. Important to have that thing securely in that little hole. And of course, it's not. We'll fix that in a second. So make sure that's nice and tight. You want to adjust the steam jacket so no part of the rod is sticking outside in air. So make sure everything's nice and snug. And what I'll be doing in the lab when I do the real experimental runs, well, I'll be leaving everything just sit for 15-20 minutes by itself. I'll go off and have a cup of coffee. Just allow all the temperatures to come together to know we're not going to film for 15 minutes.
Bro, I have plans.
Yes, to be my
That
videographer.
ain't it.
Okay. So we're not going to do 15-20 minutes here. Okay. So once everything's put in, we get everything set up. We would then come and use the dial here to zero out the gauge. Zero the gauge.
Oh my god.
Oh, went over. Went too far. Oh, perfect. All right, we're done. Now, get some initial temperatures. Which here shows 23.4. And basically now just plug it in and let it do its thing. Now it's supposed to just sit, wait, and see what happens, and we'll come back in about 15-20 minutes.